Okay, so how do you verify Rolle's theorem on this given interval? We're going to look at 67 here for a second. Now, I don't know what this function looks like. I mean, I can find out by graphing it. I have an idea what it looks like, but anyways, that's beside the point. How do we know, how do we verify Rolle's theorem? Well, there's two things we have to do. We first have to show that f of a equals f of b. And then we have to show that there's a c that when I plug it into f prime, I get 0. So these are the two things you would have to show that Rolle's theorem holds right here. So how do we show that f of a equals f of b? Well, you just plug in the 3 and plug in the 5. That's all you got to do. So we plug in the 3. We get 3 squared over 8 times 3 minus 15. And on the other side, we'll plug in the 5. We have 5 squared, 8 times 5 minus 15. All right, so we get 9. Underneath that, we have 24. 24 minus 15. 24 minus 15 is... Yeah, is that 9? It's 9, right? 24 minus... Yeah. Okay, and then we have 25, and then we have 40 minus 15, which is also 25. Oh, okay, so these equal each other. 1 equals 1. Yay. All right, so we got that f of a equals f of b. Now, what about this part right here? How do we show that there's a c that equals 0 if we plug it into f prime? Well, we're going to have to take this, this function right here and take the derivative of it so that we can find f prime. So, f prime equals f prime of x. We're going to have to use the quotient rule since there's a binomial on the denominator. The derivative of the top is 2x times the bottom, which is 8x minus 15. Subtract the top times the bottom, which is just 8, the derivative of the bottom. And then I have to put this wall right here. Okay, and then I have to square the bottom. So I have 8x minus 15 and then squared. All right, so where does this equal 0? Alrighty. So I'm going to take this f prime out, and I'm going to plug a 0 in right here. So this is f prime equals 0. Where does it equal 0? Well, let's solve it and find out. If I multiply both sides by the denominator just goes away on this side, and then I stay with 0 on the left side. So now I just have 2x times that, 2x times that. So I get 16x squared minus 30x minus 8x squared equals 0. And so I just have the numerator now. I simplified a little bit. I distributed 2x to the 8x. I got 16x squared. 2x times 15, or negative 15 is negative 30x. And then I had to multiply those two, so I have negative 8x squared. And when I simplify a little bit more, I get 8x squared minus 30x equals 0. Check it out. We factor out, what can we factor out? An x and a 2. So I get 4x minus 15 equals 0. What are my two x values that would satisfy this? We have 0 for this factor, and then for this factor, it would be 15 over 4. Positive 15 over 4. That's right. Okay, so, hey, are one of these the c we're looking for? Now remember, the c has to be between 3 and 5. Well, 0 is not between 3 and 5. What about 15 over 4? How can I write 15 over 4 as a mixed number? That would be 3 and 3/4. Because 4 goes into 15 3 times, there's going to be a remainder of 3, so I have 3 and 3/4. And 3 and 3/4, is that between 3 and 5? Heck yeah, it is. Check mark. Therefore, Rolle's theorem has been proven. It shows that it works for this particular problem. Good question, Nico. So if this was not proven, if f of a doesn't equal f of b, like what we are able to show right here, then Rolle's theorem would not be able to work because they have to equal. And then same with this part. If I found my two numbers right here after I solved this, and both of these numbers are not between this, then it doesn't work. It's not been proven. But I mean, if these are equal to each other, then this has to work. So if it doesn't work, then you probably made a mistake somewhere. It has to. So that's